Hello, and welcome. Give me just a second. I will turn off my, I would call it, monitoring for microphone. There is like limited amount of my voice that I would want to listen for half an hour. So okay, I hope everyone has a great day and you're staying safe, staying healthy. I'm continuing my small kind of adventure or journey with a project called Hitboxing. It's all about a small program that should help me with visualizing moving square that is supposed to intersect, I would call it like that, overlap with other squares. And in case this happens, those squares should change their color. That's like the way to indicate to me, to a person who is working with it, that this overlap happened. And this is like the basic stuff for some 2D games and for some, I guess, 2D programs, I would say, that may be like when you're resizing web page in your browser or something, there can be some overlap because it was designed like that in CSS and HTML. But nevertheless, 24 days. Yes, my plan for today. This program is sort of finished, but I guess for keeping it simple and not over engineering it, I would say, I really want to keep it to work only with square shape for player. And for this, I want to rename some stuff. And I would say that in this code that is based on libjdx library, most part is pretty straightforward, I would say. There is something for rendering, there is something for setup, something for finishing all the program, something for input, but I have one really specific part that can look really intimidating, and I really want to show like why it exists and how I would approach it if I would never, if I'd never heard about it earlier. Because I can say there are multiple links and articles that you can read, but why the heck? If you have working code and you can experiment with working code, I would definitely suggest this. So, project is still Hitboxing. I still use IntelliJ IDE. It looks a bit like a spaceship, but nevertheless, if you had imported your project, any project, using version control system, then you should see a tree structure of folders and files, and the first one that will be an entry point for your program is desktop launcher that starts this hitboxing class instance, and this hitbox class is actually in this core src hitboxing. Here you can see many interesting things, like it extends application adapter, like why? It has some game state, nice. It also has some setup rectangles, fine. It has create, we definitely should think about it. We have handle keyboard, we have check exit, we have apply player input, we have calculate player collisions with rectangles, nice. And we have get poly sprite, just because why not. Just a second. Yep, so we also have this render stuff. Dispose is just, yep, when our program is exiting. So for desktop it's fine. We can't even do nothing there, and it would just fail and no one would care about this. So what I want to change. Currently I have a special class that I use for keeping all the data for the entity of my player. Yep, I'm moving one particular shape. Currently, why I'm speaking about this? I have this green rectangle to start the program. Let's do it. Here we should see multiple steps of actually assembling our program, because the code that you see, it's called source code. It's not actual stuff that our computers are executing when we ask them. No, there is a special step that turns all this human readable code into some machine readable code, and this machine readable code is executed and you can see stuff like this. I'm using arrows on my keyboard, and as you can see, I have this really nice square that is moving and turning other squares to this shade of green. Nice? Nice. I named it rectangle entity, thinking that I would make slight changes for different sizes and shapes of rectangle, but then I understood that okay, then I would need some smart logic how to actually put a texture on it, because it would be like stretched in different directions. It would suck, I would say. Then I thought that if I would decide to rotate it by 45 degrees, then I would have issues if it has like if width and height are not the same. I have multiple small stupid details that I have to code, and this would make this program harder to understand, but not that really more interesting for reading. So I would say right click, refactor. I want to rename it. This definitely should be a square entity. A square. Yep. It should have not width but side. Not died but side. Yep. And this side should be set through constructor. Yep, previously there was width and height for rectangle. I decided that I don't want to have two different pieces of numbers for this. I want to have exactly one, because I have a square. So now I am changing the details of how I create this, I would say, structure with all the necessary information for my player, because I need coordinates, I need rotation where it's looking now, I need default speed of how fast I want it to move. Yep, and additional information about direction. So side, it says, what does it says? Okay, that's not what I want. Should it be like this? Yep, alternative to the left, it's just moving files. Okay, Control, Alt, and to the left, navigate, let's check it. Back is Control, alternative left. As I said, there is side. I want it to be side, but why is it cannot resolve symbol? The main issue with programming languages is that they were designed to be human readable, but the program that actually turns this human readable code into computer readable code, it actually doesn't care about your feelings, and most of the time suggests some weird stuff. In that case, it says if it's a class and you are setting something that belongs to this class, like it's some internal value, it should be somewhere in the definition of this value. And you can see x, y, width and height, and here you should see something like side. And now we have fixed the issue with like this red stuff. We still have one related problem, but this idea is trying to really help us before we fixed the basic stuff. So this class is okay. We have two warnings, like y, square entity 6, and why is that an issue? Problems with Why? Okay, it's not that helpful, as it tries to say us that we have a dependency, a usage of this class, and it changed like contract, like details of usage, and we haven't changed program for this. So now we want to do. Previously there was like x, y, width, height, rotation and speed, and now we use only side, so I removed one number to keep it easier. We also have 15 red errors. 15, oh my god. So cannot resolve width or height. That's correct, that's the stuff I disliked about this and I wanted to fix. It was previously correct. Now I'm moving back to previous solution. So, yep, that happens. Half side is player. So now question, what I'm doing? I have a piece of code that does not allow my player entity, this square, to move beyond the screen limits. So if you move to the left, you wouldn't go away and you would just stare at the screen and there is nothing happening. That's kind of boring. I decided that I want to limit its movement by checking if coordinates or the center of the square are not reaching like x equals to 0 and x equals to width of the screen. I have values for width and height of the screen that I'm using, but the trick is we have a square and x and y are in the center, so I need to compare x not to the 0 but to the half of the side of my square. Get it? So I can show it like this. We'll make a half side. It's sort of looking boring, but I definitely don't know how to make it easier to like there is some complexity to any program that you're writing, and some complexities can be hidden and some complexities are just the core of the program that you're trying to write. So if you're trying to make a calculator, you can try to hide the calculation stuff, like when you add one number to another one, but it doesn't make sense because it's the heart of your program and you have to do it. So in my case, limiting the movement is sort of like I want it really to work and I have to implement it somehow, and this is the most straightforward way. I'm checking the x stuff, x component of coordinates, then I'm checking y components, and if some of these conditions work, then I have a default value to use. Okay, so one more boring minute or two. Okay, y have red here. Okay, there is player sprite. Yep, it's for rendering our player. It needs these. Oh, I need it also multiple times. Okay, I'm fine with it. Okay, there is a way when, so there are like two separate problems that we have. One of them is actually managing the internal state of our program, like where is our player right now. It has coordinates, right? And it's moving in its own virtual world. And then you have a problem of how we're gonna show, how we're gonna project this virtual world on a screen, on a physical screen that has like number of pixels. It has like, I would call it an operator, or like a place, a camera that is looking at this like particular 2D virtual world. And there is like boring stuff like library that is drawing images it just doesn't care about details of our world, because we haven't made an additional abstraction to hide this thing. So we have some, like, I would say, we have some calculations that are happening inside our virtual world with all these coordinates, and then we have these calculations that are related only to showing graphics side. And while in our imaginations they are sort of like tied together, in reality you have to program this like relation between them, and you can have many issues if you have some issues on your like internal logic and it spills into drawing graphics, or you can have super nice internal logic but you have failed somewhere in drawing stuff, and you can't like guess why. So I'm using an approach that every time you have like 1/60th of a second, one frame, you are drawing everything from the scratch. You are clearing all the screen, then you're taking the image of your player, you're using coordinates for its size in pixels, and you draw it on a screen like it's an image. So your data about player is converted to actual directions of where you want to put this image in this scale. And that what is happening right here, and that is why it needs data about like a center. Where is the center of an image if I decide to rotate something, and I have rotation, and also the like actual scale, because you can have a huge image and you still want it to fit into 100 pixels. That is also a problem, but only on graphics side. So we have 3 more issues. Okay, I guess they are about side half. They are all about they're all about collisions, because previously I had this mumbo jumbo player width, yep, half diagonal, yep, but why it's like this? Oh yeah, so geometry side is still the same. We have the side of our square, and we have diagonal, because we can rotate our square by 45 degrees and it would get like a diamond shape, we would call it like that, and we have to have actual like pixel length of where we would put dots that combined will give us like corners of our square, something like this. So with this is like player height half diagonal. Oh, it's like just a side half. Yeah, but it's just we have 2 states, one diagonal, one straight. And that's it. Should I change something else? And what is the problem exactly? Am I copy pasting something? Oh, no? Redundant recreation for calling work. That doesn't matter for me. It doesn't matter for me, like at all. So let's give it a shot. If my changes are correct, then you should see pretty much the same thing. This square, that is now a square entity, that is moving, and you have seen, yep, it can move in diagonal direction. And this is handled properly. Nice. Nice. So what I wanted to show, that you can move to the left, or to the top, or to the bottom. And yep, it's not because it's an error, but my screen is just limited. I want it to the top. Nope, you can do this. You I wouldn't call you who. Okay, so you can see that it's moving and just stopping. Tin tin. You have just, it's a bit stretched because like original height was different. I can fix it. It should be like this. Let's give it something like 1000. It's like initial height for our game screen. Yep. So now it's definitely square, and you can see when I'm moving to the left or to the bottom, this triangle shape is the same, just rotated. Nice, nice. So if I would say that, okay, like, okay, nice piece of code. I can see this sort of bullshit that you added with this side half. I'm not sure that I need it. Maybe we can just remove it, right? Because who cares? It just makes this piece of code like more difficult. And I wanted to see it in easier way. I say, okay, makes sense. Why would I use something like this when I have, if player X is more than screen max width, then it should be screen max width. So if I'm moving my player to the right, it can have only its maximum value is screen max width, and if I move it into the left, it can have only value of 0. And the same stuff for the Y stuff for vertical side of things. So let's give it a try. When we move it just in the center of our screen, everything should work as expected because we are not hitting any limit. But what if we move to the bottom? Okay, that's kinda nice. What if we move it to the left? Oh, we should move it a bit to... Yep. Well, it's kind of wrong, right? So you can see a half of the square with a triangle, and why half? And as I said, when I'm drawing stuff and when I'm thinking about moving my player, I'm thinking about moving its center. But when I made this logic of limiting its movement, for some reason, I'm not thinking about size of my player. And it has actual size on a screen. It's not 1x1 dot. If it was a dot, then yes, it would be correct. But in this case, it's a square with a side of 100 pixels. So I should accommodate to that, I should be aware of that, and I should get back to the code that was previously written. So let's check it again. I'm adding half of a side, because if we have 100 square, and for example it's in the beginning, in the left bottom corner, then it means its x is about 50 and y is about 52, and 50 is exactly the half of a side of a square. So let's check it again. And yep, left, yep, it's working as I expected. That's nice. So just one boring side. As I said, I'm doing my best to keep things simple, and if I see that I made some changes that can be sort of considered one meaningful change, like rectangle player fair and square player, no. Okay, and what yep, just to show that so when I made some changes, I usually try to add them to the repository on this service so that if someone would want to use it, it's in here. I did it like right now. And if you wanted to know, yep, rectangle entity was renamed, and we added like changes for using constructor. We made some parts easier for understanding. Yep, and this also got easier for me. Side 2, that's fine. And yep, we made height a bit, I don't care. Nice. So what now I wanted to talk? I wanted to talk about, I would say, the great. So if you had some experience with reading code, you can get like, okay, in the beginning of a file, this is something written elsewhere. That's what it means. So I am writing a new piece of code, but I am using previously written code to make it faster. Like if you would say, I'm writing a new like scientific article, and I say that I worked with this, and this, and these are like dependencies that you definitely should check if you want to understand what the heck is going on in my article. So okay, then you have the naming for a class, for a structure that is keeping all the logic that I need. This structure contains some variables. Each of them has its own special type, which is sort of useful when you get to work with code that has no typing. And what else? Yes, it has a state for all the program. It has this max screen for checking if we reached the limits, and you can have smart logic for sort of changing and resizing the screen and changing these values to make it dynamically like dependent on the actual screen size and not on default values from the beginning. Yep, we have initial coordinates, initial speed that we can always change. Yep, we have initial rectangles set somewhere in the create, and also like, how is it called? Loading image. Yep, all this necessary stuff is done. Also additional checks for escape and space buttons made through this API. That is fine. When we actually go to the logic, everything happens not inside all the functions, but there is one main entry point for the logic. It's called render. I have a special document place. It's called readme, and you can see that we use a game loop approach. We have a setup phase, and we have loop phase and exit phase. In a loop phase, everything that you see here, it's actually in the render method. So when we get back, render method, we can see there is input handling for keyboard for checking if we should exit. We have this fixed timestamp logic handling. So like what? Then we have while internal timer tracker fixed timestamp max update. Like, this doesn't make sense. Apply player input. Okay, calculate player collisions. Nice. So some internal time tracker iterations. What the hell? And then we can see rendering with clearing, with drawing some rectangles, with drawing our player, and that's it. But why is this while loop here? So let's see again. Do we see in the documentation anything about this while loop? Apply input, collision detection, state change, clean screen, maybe clear screen, render stuff. So what the heck is going on? And that's the part where you can have like two main strategies that I would suggest. So first of them is actually try to read about fixed timestamp. What the heck is Yep, so fixed timestamp in game loop. You just randomly, as I would say, you're just doing something like fixed time stamp game loop. Game loop. Why interpolation? Fix your time step. Time step. Okay. Why use integration for a fixed time step game for loop? Okay, and there are like tons of questions and answers from multiple years. Some of them here. And you can say, okay, there is quite a long conversations. Okay, maybe this one. Oh, it's an article. What we can see here? Oh, I can see this. I can see current time, quit. I can see render. Oh, I can see while. Nice. And then I can see accumulator. Like why? Why is it like this? You can see accumulator plus frame plus alpha. Doesn't make any sense. I need to learn it all. And the actual point is yes, you sort of, if you really want to understand what is happening, you would need to check those articles. But before, like when someone has understood something, the main thing that they're missing is the feeling of being a novice in this topic. If you ask a friend who is already programming for some years and you would ask like, how should I start? You would, like, if he's not a teacher, if he's not working with actual people who are starting the journey in programming, usually you would hear something that he in his current state considers to be difficult. So if he is like learning something about object-oriented programming or architecture, he would say, oh, you know, everything is easy except this topic, you know, this is really hard. You definitely should think about it too. I have so many different books or something about it. And you're like, sorry, what? I don't know what the heck is going on at all. I'm not sure that I need this. No, you definitely need to know about this OOP stuff. It's really important. And I'm not saying that it's not important. I'm just saying that people forget just how much of an effort it was in the beginning to understand something. And then after years, they consider it something like everyone knows it. So I wouldn't spend my time describing these little details because like I know about them. Definitely was easy for me. Yeah, it was easy. You spend just some years for understanding it, for somehow building, I would call it a mental model of programming, of computer inside your head. And now, yep, either you wouldn't know that it's still difficult for you, or you definitely grasp it and you just feel it as something natural for you. Like for us, it would be really difficult to remember the times when we didn't know how to walk, if you haven't like broke your spine or something. So when we were infants and we didn't know how to walk without two like legs, and now we do it without thinking because we have so much experience with it and we wouldn't even consider it a skill. But if you would try to write a program that moves some random something with two legs, or if you would write a program that moves, for example, a spider with multiple legs, you would feel like it's hell of a problem just to think about it in terms of like numbers and joints and weight and everything. And I wouldn't even think about like a spider moving on from the floor to the wall, for example. How should it move to work as expected if you see a real spider, not without different light sources and reflections. No, just physically. Like where would his legs be? where would his body be? Would it like bounce somehow? Would he move like it's a train or something? So it's hell of difficult. So what I'm suggesting, without this mumbo jumbo, try to take a piece of code and make it so that you can understand it. So when I opened a program, so the idea is, if you can see a program and you can run it, you can check one line, for example, iterations, and max update iterations. What is this? It's 3. What if I say it's 0? What would happen? And you just run it. So what would happen here? I'm moving, I'm pressing buttons, but nothing is happening. That's weird. Okay, what if I change it to something like 1? Okay, let's move again. I would say everything looks fine to me. Except maybe 1. Oh, why it's moving so strange here? Nice. So yes, it's sort of fine. So you haven't broke anything. So maybe it doesn't make any sense here, right? So maybe we can just remove it and it wouldn't break anything. Because I can see iterations here, I can see that it's somehow related to this. So what if I do it like this? What should... It almost feels like everything is fine except something with its movement is changing. But how? Like why? Why we see... Sometimes if you look closely, you can see that sometimes it's moving like smoothly, like butter, but sometimes it has like this jagged behavior, like if something is missing. It's sort of, you have to see this thing, like when you see it, like why? It's just like when, you know, when you're playing a game and you're losing frames. It previously was something like 60 and now you have like 37. Like what is happening? Like what is going on? It feels like I'm missing frames from a cartoon, and it makes it feels like why? It makes you lose this like illusion that it's real movement of something, because it's like based, all this game stuff, it's actually based on our like brain activity. And if you think about cartoons or movies, they actually were invented not so long ago, because we have a really specific behavior like built in our head. So when we watch changing pictures, if we have like 10 pictures, it looks like, okay, 10 pictures. But if you change about 24 or 28 pictures in 1 second, for some reason our brain decides that, oh, it looks like a reality. I can see the relation between those images, and I consider them one like smooth movement. So it's like real for us, for our brain. It doesn't care if it's not a real object, like physically. It can interpret it in such a way that it considers this real. And that is okay, because you can definitely watch movies with people and not think about, oh, how long I'm gonna like sit here and watch on this like 2D screen with all those changing lights. No, you're thinking about people. You're not thinking about like solid 2D screen, because there are no people in front of you. It's a screen. Those are just images. And if we're speaking about cartoons or movies, there is this concept of changing pictures that we need to use to trick our brain in thinking that it can see something actually moving and not a number of images. So we're actually generating these frames on the fly with our program. Why we're generating on the fly? Well, because the player is in the driver's seat. He's deciding what he wants to see next. In case of movies or cartoons, you always see the stuff that was made for you, so they can have limited frames per second values, and you have no issues if you are not streaming it, and you have no issues with internet and so on. But if we consider it's like a local movie theater or local computer that you're looking on your file and you have a decent computer, then you just see a stable number of images on your screen and you consider it fine and it doesn't bother you. So with games, it's pretty much the same. When you see exactly, for example, 60 frames generated per second, you consider this movement as smooth and correct, and that's cool. But there can be an issue. Computers are pretty tricky beasts, and we are not writing in some super low-level language to consider it super optimized for these frames per second, and we're using other people's code, different frameworks, libraries, engines, and you can even implement stuff for different game consoles which have their limitations for things that you can try to calculate in 1/60th of a second. As I said, if you are generating 60 images per second, it means that all your calculations should happen in a 60th of a second. It's like in human perception, we wouldn't even perceive such a small amount of time, but for computer it can be like a huge time, I would say, slice, and they can try to make many things in that moment. So as I said, we have these render and we have these fixed timestamps something. The idea was like this: if you imagine that your computer always finds enough time in this second to make 1/60th of calculate, so when you move to the right, if you think that your computer is so stable that each 60th of a second it would calculate everything correctly, then you will be in a world of pain, because it doesn't happen like that. Sometimes, most of the time, 90% of these seconds, yes, 90% of these frames, it will be like that. But sometimes, for some reason, you will see a small lag that would affect how your player is moving. And this is a problem. So let's do it like this. I don't care about calculating, doesn't matter. I don't care about this. I don't care about while loop. I don't care about anything about boring. Okay, as you can see, I set only apply player input. So I am thinking about only when I pressed right, I want to move it exactly on some length. So for example, 5 pixels per press. So if we do it 60 times per second, then it would be about 200 pixels. No, maybe it's too much. Maybe we should move it exactly 2 pixels. Sounds about right. It's okay. Apply player input. For example, we're checking if we can move. Nice. Direction. Something with sine, cosine. Okay. So step is... No, I want to use exactly 2 pixels. Okay. and I want direction. Direction multiplied by step. Yep. Rotation. What about diagonal? No? Okay, direction already has some tricky magic there. Okay, that's fine. Okay, let's give it a shot. How would it look? So now you sort of get to the low level of our program, and what is your expectation? So you have this square, and now you're gonna press right button. What do you expect from your program? And this is like the most important topic, because computers are not understanding your thoughts. You're sort of communicating with your computer, and you are asking him to do the things that you think he should do. He can do anything you would ask him. Like if you ask, like, remove all the files on your computer, he would do it. He doesn't care. If you have no operating system or some other way to block you, he would do this. And in some cases, on some operating systems, you have this ability to wipe everything away. And I'm not saying that it's a good thing, but it can be done. So every time you're making changes, you can have a theory, like what I expect from these changes. So I would close the program right now and we'll again check it. So I have this player input. We check keyboard state. If buttons are pressed, we convert it to some sort of values like 1, -1. Same thing for vertical part. Okay, then we get some sort of direction. Then we get some angle, okay, that we use for some value here, that we multiply by our step, that we expect it to be 2 pixels, and we add it to existing coordinates. That's it. Then we save rotation just to render it properly. Okay, so if I'm pressing right, and I know that I have like 60 frames per second, why I know this? Well, because I wrote fixed timestamp here. Actually, I'm not sure that it would work right now like this. It would work like... yeah, I'm not sure that it would just consider it to be... like in this case, it would be CPU dependent. It wouldn't care about time. It would just work as fast as possible, and if we have some background processes that are using our CPU, it would work slower. If we have no thing to slow it down, it would work super fast. That's my theory, at least. Let's check it out. Okay, I'm pressing right. Oh, it's not that fast. Quite smooth, I would call it. I guess my laptop is working pretty fine. No, I would say nice. Okay. Delta time. Check exit. So let's move it a bit faster. Maybe we could see something if it would be faster. Okay. Again. So now to me it moves like with no issues, because I guess if there was I'm not sure how it's looking in streaming, but to me it seems like it's working really smoothly. Okay, so for example, if I decide to do some calculations. Because I need calculations, right? Everything works fine from my understanding. I want some really nice. So my theory was not correct. That it would move really fast. Moves pretty fine. Like, do we have... We have no frames here. So maybe it has internal logic that tries to have as many frames as like hertz set for my screen, and it's 60 hertz screen. Okay, what if I decide to make it like multiple times? Like would it even somehow affect what I'm having? No, it's like nice. That's cool. Interesting. So I don't need it. Fixed timestamp. It's okay. Let's move this back. And I would say it's kind of interesting that it doesn't affect like powerful PCs, I guess, because I'm not doing anything super special right now. So I made the speed triple the 515. Huh. Interesting. So as long as I'm writing program for my PC and my friends are using pretty fast PCs, I can sort of not think about the issue, I guess. But but let's make like, as I said, when you have something that you plan to change, there is a way of changing code, and there is definitely a solution, but sometimes it can be really difficult to just change it right now. And in this case, when you're checking this sort of really fast generation of images, using debugger can be sort of meaningless, because you expect to think about something that happens 60 times per second. Like, how would you debug this stuff? Because every time you debugging something, you're actually pausing everything. So in this case, we definitely should lock something. And just for simplicity's sake, let's return everything to the state where it was. Like, okay, I want this. And what about max update iterations? Okay, so that was it. Fixed timestamp. What is this fixed timestamp? How we are using it? We have internal time tracker that gets delta time. Okay, so what is this? Aha. So interesting. Oh yes. Control Alt left. So, returns the time spent between the current frame and the last frame in seconds. Might be smoothed over and frames. Get the raw delta time without smoothing. Okay. Get frames per second. Average number of frames per second. Why not? And what we're gonna do now? We're gonna try to actually print the stuff. Like if we can't stop with a debugger, or for example it was executed on other person's machine, we can always try to add some logs and later save them in a file so that we can get these information in a text file and check it. Like how I would call it, like clues after some, I would know, a crime that happened on other person's machine, and there were like clues everywhere, and we combine them in one text file of logs of information, and we later can analyze it. So GDX graphics. Okay, so we can see something 5961. So as you can see, it's not that stable. Can we easily check it with our eyes? Well, on a fast machine and with nice smoothing, you wouldn't even guess that it happened. So the idea was, when you're doing something easy, I would call movement in 2D sort of easy, and you have really dumb like physics interactions, like limiting the movement to the top, to the bottom, and so on, you sort of can get away with the simplest time management. But if you would decide to use actual physics in 3D, then you may stumble upon any issues like, I would call them unpredictabilities in your physics engine, due to the fact that you are not thinking about a fixed time step for your physics engine. And there, so to describe it a bit shorter, so if you're introducing like pretty specific way of checking intersections between multiple objects with changes for their velocities, positions, like different other like properties, then you would definitely use or implement yourself a physics engine. And they are not designed in a way to be, how would I call it? So they're just programs, and they have their limitations, and if you were trying to do them without fixed time step, you would get so many problems you wouldn't even imagine them. So people decide that they want fixed step, and they want to always know how many steps they sort of expect for this physics engine to calculate. And if, for example, rendering of your frame took like time of 2 frames, it's not a big deal, because you can make 2 steps of calculations for your physics engine and then draw a next visual representations of this. In that case, you have like unrelated internal world calculations and rendering. And even if your rendering is slowing down from 60 to 37 frames, inside your world calculations, you would still have 60 steps per second, because usually this part is faster than drawing, especially if you draw multiple objects. In that case, you would get some jagged animation, like you can see square here or there, but if you just move it from left to the right, you can skip some of them, but it wouldn't feel like sudden slow down and then a sped up. That's what we are trying to achieve here. We try to achieve smoothness of movement by thinking about some unpredictability inside our machines and inside our code. I'll check later how it was shown in stream, because I guess stream was also 30 FPS and not 60 FPS. It's sort of difficult to check it from my simple example, but that's the beauty of simple example. You can always remove or comment out some pieces of code and it would even be working properly. That's it. So what I wanted to say, I would consider this project to be finished because I wanted to know how I can approach should be code. That's nice. So I wanted to make a program that allows me to move a square. Currently it's a square, not a rectangle. I wanted to move a square that is intersecting other squares and they're changing colors. That way I consider this overlaps a collisions, and I have a technical approach how to consider if in this situation my pair is intersecting with something or not, and I have sort of easy mechanism how to visualize it. I have a keyboard that I use for actually moving stuff, and it works pretty nice. So it looks like finished demo of this collision logic. If for some reason you would decide that maybe you want more squares on your screen, or maybe you want them of different sizes, maybe not squares, maybe polygons, you can try to do everything from scratch, or maybe take something like this small piece of code and try to, I would say, hack something with it. That is the beauty of programming if you have source code and correct build and IDE for working with this source code. In that case, any other language is fine as long as you understand how it's working, how to change something, how to add login information, and if it's fast enough for your tasks. Yep, that's it. That's it for programming. So yes, I'm not sure that it was the most entertaining stream that I had about this topic, but I'm really excited that I can sort of finish working on this, like collision stuff, and maybe think about something else. I'm not sure yet what I would want to tackle next. Like, do I want to move some other objects using my object? Do I want to think something about graphics? Or not? I have like 3 topics that I'm really curious about. So one of them is I want to have like an explosion. So I'm moving a square, right? Then I press, for example, space bar, and I want to see an explosion. How would I approach programming it, and how would it be easy for me to understand and to describe like what is happening? The second one is like, as I said, trying to move some squares using my square. So not when overlap happens, maybe I want to move the objects that I'm bumping in. That would be kind of nice, but it's also not the most interesting thing for me. And the third topic that I have in mind is actually about jumping. So in case you decided to make a 2D platformer, right? Like Mario, Sonic, anything. Like they all can jump. So in most 2D games you can jump. And there are multiple ways how you can implement it. In some cases you can control the jump in air, I would say you can control the height using the information of how long the button was pressed, and you can control sort of the like, not the line, trajectory, I would call it like this. So you would control the path that your object is like moving through when you hit the jump button. There are many different kind of jumps, different kind of games, from simplest to the most like insane, where they're like ability to change directions multiple times. But we definitely need to start from something, and I would call like this thing seems like it should be cool enough, I guess, from hitboxing to jumping, because we still have a floor. It's sort of simplest hitboxing. And I would love to dive a bit deeper into handling of input, because animation, still it would require for me to draw something or get some inspiration from internet with the images. And from my understanding, any animation is just a series of images, but I just need to be sure like which images were shown and for how long to make it look nice. Okay, that's it for today. I hope everyone had a good time and will have a great week this week. So thank you. See ya.